Have you ever wondered what protects a planet from the fury of the sun? On Earth, it's our powerful magnetic field, a global shield that deflects harmful solar radiation and preserves our atmosphere. But on Mars, that shield is mostly gone. Billions of years ago, Mars may have had a magnetic field like Earth's, but something caused it to shut down. Without that protection, solar wind, streams of charged particles from the sun, began to strip away Mars' atmosphere. The result? A once wetter, warmer planet turned into the cold, dry desert we see today. When intense solar storms erupt from the sun, like coronal mass ejections, they slam into Mars with incredible force. These storms create electric currents in the planet's thin upper atmosphere, trigger ghostly auroras across the entire sky, and accelerate the escape of gases into space. NASA's MAVEN spacecraft is watching it all unfold. It studies how the sun's energy interacts with the Martian atmosphere, helping scientists understand just how much Mars has lost, and how fast it's still disappearing. These findings are crucial for future human missions to Mars, where astronauts will need protection from this invisible, electric threat. Without a magnetic umbrella, Mars is constantly under fire, and each solar storm tells a deeper story about what Mars was, and what it could never become. True or false? Mars currently has a strong, Earth-like global magnetic field. False. Mars lost its global magnetic field billions of years ago and now only has localized magnetic regions. What causes Mars to lose parts of its atmosphere over time? Solar wind. Fill in the blank. Mars lost its global, blank, field billions of years ago. Magnetic. Fill in the blank. The sun's charged particles are known as the solar blank. Solar wind. Which NASA spacecraft studies Mars' upper atmosphere and solar interactions? MAVEN. If solar particles travel from the Sun to Mars at an average speed of 600 kilometers per second, and the distance between the Sun and Mars is 225 million kilometers, how long would it take the particles to arrive? To calculate how long solar particles take to reach Mars, divide the distance, 225 million kilometers, by their speed of 600 kilometers per second. That gives us 375,000 seconds, which equals just over 104 hours. True or false? Solar storms can increase the rate at which Mars loses atmospheric particles. True. Fill in the blank. The spacecraft studying atmospheric loss on Mars is called blank. MAVEN. What is created in Mars' atmosphere when a solar storm hits? Electric currents. Fill in the blank. During a solar storm, Mars experiences invisible blank in its atmosphere. Currents. True or false? The MAVEN mission helps scientists understand how Mars interacts with the solar wind. True. If solar wind travels at 500 kilometers per second and impacts Mars continuously for 4.5 hours, how far does it travel in that time? To find the distance, we start with the speed of the solar wind, 500 kilometers per second. Then we figure out how long it's been traveling. 4.5 hours means we need to multiply by 3,600 seconds per hour, which gives us 16,200 seconds total. Now just multiply the speed by the time, 500 times 16,200, and you get 8,100,000 kilometers. That's how far the solar wind raced through space while hammering Mars. Martian auroras are most visible in which part of the electromagnetic spectrum? Ultraviolet. Fill in the blank. Mars has small magnetic zones trapped in its blank. Crust. If charged solar particles travel 135 million kilometers to Mars in 75 hours, what is their average speed in kilometers per second? Divide 135 million kilometers by the total number of seconds in 75 hours, 270,000 seconds. That gives us an average speed of about 500 kilometers per second. How did you do? Tell us in the comments below. And thanks for watching Brainy Kids. We hope you had fun today. Like, subscribe, and hit the bell so you never miss a quiz. See you next time, brainy friends.